Hello everyone, welcome to our channel. Today I'm going to explain the Dijkstra algorithm code. I'll not explain the program, I'll explain the code. I'll not explain the algorithm. Algorithm is very easy, you can understand it, but the code is bit tough. I'll explain it. So first what we are doing, we are creating a class called Dijkstar. In the Dijkstar, we are making three arrays. First one is distance array, then is a path array, then we have a visited array. Then next we are making a method called dijk, which is a short form of Dijkstar, and it takes three parameters, namely the array A. Then it is taking the parameter int s. Int s is nothing but the source element. Next one is the number of elements in the number of elements we are taking, or number of the vertices. Next we are having some variables. First one is u, it is equal to -1. Then we have a variable v, then we have I and j, then we have minimum variable min, we call it. First initially what we are doing, we have declared three arrays, right? We are making first we are making distance array, all the elements of distance array equal to 99. We are making all the elements of a path array is equal to -1, and we are making all the elements of visited array equal to 0. Afterwards, whichever vertex we are taking it as source vertex, we are making the distance of that as 0, because we can go from source vertex to other vertex, but we can't come we can't go to like going from source vertex to source vertex distance is obviously 0, so we are taking it as 0 first only. Then we are taking a for loop using a variable I, that is we are using for row. Then we are making minimum as 99. See, because in the distance array we have taken it as 99, right? Max value or min value, we are taking it as 99. Next for loop, we are using it for the number of columns in the rows. Then we are checking here what is a condition, what is a if condition. If the minimum value is more than the value present in the matrix, that is distance matrix, or if the distance vertex is less than the minimum value and it is not visited, if that vertex is not visited, so visited is equal to 0, then we are choosing the minimum value as that vertex value, that is min is equal to d of j. This is the distance. Then what you are doing, we are using a variable called u and assigning the vertex value to u. Then next we are making that vertex visited as 1. We are coming out of the for loop, we are coming out of only one for loop, not both, only one. Then again we are using one more for loop, and we are going on searching using a formula, that is distance of u plus cost of, this is a cost matrix, weighted matrix, we are taking this as an input, cost of weighted matrix. If you combine those values, is it less than the cost of the or distance of the vertex v? If so, and we have another condition that u must not be equal to v and visited of v should be equal to 0. If these all conditions are met, then we are making the value of dv as the combination of distance of u plus cost of u and v. Okay, this we are getting from the weighted matrix. And in the path matrix, we are choosing the path as p of v as u, or it is equal to u. Next, this is the overall Dijkstra algorithm. Now we should print the path. How will you print the path? So we are using first, there is a path method and there is a display method. I'll go to display method, then we'll come to path method. Okay, for display method, what we are choosing? We are choosing a source vertex, then the number of vertices. These are the two parameters we are passing through the display method. Next, we are using a variable called I. Then there is a for loop. In for loop, what we are doing, we are tracing. We are going to trace it. We are tracing all the arrays. So first, what we'll do? First, we have a condition that I should not be equal to s. What is a condition? We are tracing all the vertices from source vertex to end vertex. So first from 1 we are starting, we are going on tracing all the vertices. First we are printing the source vertex, Then we are going to a function called path. Now I'll discuss about path. What is this path? Path will have two parameters. One is the vertex and another one is source vertex. If the like path if till we are using a if condition, that is path of v not equal to -1, till this is not equal to -1, we are going on pushing the elements. It is just like a stack operation. We are going on pushing the elements using recursive call. See, instead of int v, you are pushing the element p of v and source vertex, pushing till we get -1. After that, what we are doing? We are popping it out. How we are doing? We are popping it out till vertex is not equal to v, and we are printing that. Okay, we are going to print it. We are going to print all the elements. Next, then this is done with the path. We got the path of elements. Next what we are going to do? We are going to print the value of that path. What is the minimum value? So similar same condition, if I not equal to s, then we are going to print it d of I equal to these many values. Then after that it will go to the next line using this code, that is system.out.println. It will go to next line. Again the iteration will start. Next it will find another path for another vertices, so it will keep on continuing. This is the work of display and path, and this is I have explained also the function Dij, that is Dijkstra algorithm. This is the overall Dijkstra algorithm logic. Now I am going to explain the main function. It's very simple, nothing to worry in this. We have a main function. We have a two-dimensional array because we are taking a weighted matrix. Then we have a 4 variables. First two I and j for row and column, you already know. Then we have we want number of vertices. For that we are using n. Then we want a source vertex, so that we are using s. Next, first enter the number of vertices. We are entering. We have a scanner class. Then we are storing the value in n. Then we are entering the weighted matrix. We have two for loops for row and column. Then we are storing the value in I of j and I, means ith row and jth column. We are storing all the values. Then we have a system.out. We enter the source vertex, storing it in s. Then we want to declare the Dijkstra class object. We are declaring that. Then we are passing the parameters to Dij method. We are passing the array. Then we are passing the source vertex and number of vertices. Done. Now we want to print the shortest path. So we are calling another method, that is display. We are passing source vertex and number of vertices. The vertex will be the shortest path between will be printed. Okay, now I'll run the program and show how it works. See, I'll give number of vertices as 5. Then I have already copied the weighted matrix. Done. I'll give source vertex as 1. Done. See, we have got the shortest path. I'll enlarge it. Okay, we got the shortest path between source 1 to the remaining vertex, from 1 to 2, 1 to 2, 1 to 3, then 1 to 4 we have, 1 to 5 we have. Okay, if you check this, if you convert this into a graph, you can understand it clearly. With this much, I feel that you have understood the program. For algorithm, you can see other videos also. You can understand. Algorithm is very easy, but the program part is a bit difficult. The Dijkstra program is easy, but the displaying part is a bit confusing. I feel that you have understood it here. Thank you.